Hello. Today we're going to be looking at an analytical method for the study of substances and the isotopic composition of elements using mass spectrometry. It's one of the very popular research methods used in both physics and in chemistry. What is the basis of this method? This method is based on the fact that samples of substances, elements, and isotopes are appropriately placed in the device called a mass spectrometer. In this instrument, the particles are detected. The determination of the particles through a series of steps that precede the final recording of the composition of an element of a given substance, both organic and inorganic. What is the basis of this apparatus and what are its components? What it consists of? Let's understand. So the apparatus consists of a special tube, which is called the tube in which the particles move, inside of which there are parts. The first part is called the sample input part, which is in dissolution state, which means that in this case all substances entering this mass spectrometer must be in a state of a gas. So if it's a liquid, it's heated. If it's a solid, it's also heated to a vapor state, which is to a state of a gas. This step is called vaporization. Then inside this apparatus, necessarily, this is a very important step in the operation of this, is the creation of a vacuum. And in the initial stage, it's an atmospheric vacuum. And at the end of this device, there is a deep vacuum that has a value of practically zero. Next there we have a corresponding apparatus, which is inside this device that is a part that allows to generate high energy electrons. What are they for? Well, the thing is that the sample that goes into this mass spectrometer is usually neutral atomic particles and molecules. And in order to turn them into an ionic state, they have to be affected by electrons. It's called an electron impact. It happens in the following way. Let's say we have a particle that's neutral and it's processed by an electron. It's bombarded, and the result is a particle with a positive charge, and the electrons are given off in addition. And it's the electron that's being bombarded. And these are the electrons coming in, the electrons that are knocked out of the particle. So in the second step, which is called ionization, is the formation of particles with a charge of ions. Most of the time they're positive, although they can be negatively charged as well. Here I'd like to emphasize again why a vacuum is required, why you can't do this procedure, for example. This procedure, for example, at normal pressure, because if you don't have a vacuum, the particles can reconnect with the electrons and so become neutral particles again, which in this case shouldn't happen. Then there are special electrodes that allow our positively charged electrodes, which in this case accelerate these particles that are produced in this case by the electrons. That is, acceleration takes place here. This is the process that is labeled with the number 3. Then in the path of these particles, many of these particles, there are electromagnets that create an electromagnetic field. This is where the charged particles are subjected to the Lorentz force, which causes the charged particles to deflect. And the particles that are deflected, small mass particles, are deflected strongly in one direction. But there's a high deflection. At this time, particles move in the other direction, which on the contrary have a large mass, but a low deflection. And in this case, the spectrum itself is split, so the path of the particle is inhomogeneous. This stage, the fourth stage, it's called deflection. Number 4, then there's a formal trap in the path of these particles. There's a formal trap in which these particles can be sort of trapped. And this device, this part is called detection. So you get a recording of these particles. These particles are then recorded in a special way. You know, in the past they used to use photographic effects, but now these recording devices work with more clearer examples, instruments that allow particles to be recorded very precisely. And then the recording goes to a computer, and then the computer analyzes the results, transmits and creates what's called mass spectrum. What is included in it? Mass spectra can be constructed as follows. For example, the x-axis is the ratio of mass to charge, and on the ordinate axis, in this case, we can put off, for example, the percentage of a particular isotope in nature if we're analyzing isotopic composition. Using zirconium as an example, I'd like to show you what this mass spectrum looks like. A mass spectrum like this. In this case, from the graph that we get here, we can determine which isotope of zirconium, for example, is found in greater quantities in the sample we're studying, including natural samples. Accordingly, we can use the graph to find other isotopes, which in this case appear in this particular sample. Plus, on the ordinate axis, we can also plot, for example, the magnitude of the ion current, which also allows you to detect different particles. I would like to say that mass spectrometry is not only used to determine isotopic composition, such as zirconium, but also other isotopes that are found in nature, including those that are produced by radioactive techniques. But the same method works very well in the way of investigating, for example, inorganic and organic substances that allow you to do this, to do it very precisely. This method of investigation is very popular. It's used quite widely, I repeat, in chemistry and physics. The only thing I would add is that it's not always the impact to convert particles into ions is just bombardment with electrons. It can be chemical action and exposure to a variety of both particles and, let's say, radiation. So it doesn't necessarily have to be through electron impact. So the research method of mass spectrometry is also used to determine isotopic composition, which we're going to talk about in the next lesson, and we're going to learn about using mass spectra like this to find, let's say, the average mass isotopic composition for a given chemical element to determine its relative atomic mass. Goodbye and thank you.